guys, we're going to talk a little bit about the multi-strand conductors. We touched on it yesterday a little bit, last night, and I've got some cable here that I use to mount a small winch in the back of my truck. It's a 4 gauge cable. This is a strange one because, like I said, it says gauge. It says Jaycar 4 gauge OFC high current. Hold the glasses, guys. I need to read this. High current power cable. Jaycar 4 gauge OFC high current power cable. Absolutely no idea whether it's metric, imperial. It just says gauge. Now 4 gauge, I'm assuming will be the American gauge. And compare that to, you can compare that to the 8 gauge. A little bit closer. 4 gauge to 8 gauge. You can see that or not. Look at the size difference between one and the other. That's what you would use in your car to carry 80-100 amps or something like that. At the end there, multi-strand cable, you can see that or not, multi-strand. Hopefully you can see that there, multi-strand cable. There's lots of little cable, little conductors in there, little miniature ones, which makes it very highly flexible, so that when you get vibrations in the car, it just flexes. The problem is that when it's rigid, that point where it's rigid to where it flexes can break the cabling inside. That's why they say when you use crimpers, lugs and things like that, connectors and so forth, not to solder the lugs. It's better off to crimp them. You don't solder crimp and crimp solder whatever. You don't get anywhere near solder with with lugs. It's just that they you have a connection and you allow that to flex around it. You start putting solder on the lug, and the solder runs up the insulation so far, and that section there becomes rigid, and the other section becomes flexible, flexes, and that can damage the cable up that end because it's rigid. It vibrates and it becomes rigid and breaks off, breaks the conductors internally. Then you have a hard time trying to find it because it's inside the insulation, it hasn't broken off at the end. So I'd stay away from soldering lugs and things to your cables. It's not the right way to do it. In terms of lugs, there's quite a few different crimpers on the market. Let's step back a little bit so that see a little bit. Just put that down there. We don't need that anymore. Quite a few different crimpers on the market. Yeah, some are better than others. I agree with that. You know, I've used crimpers, hydraulic crimpers on substations where the lug is that big and chunky and that fat. The cable goes in, there's a resin inside the lug to keep the moisture out. So special application lugs, they're very expensive, very good lugs. And then you put heat shrink on the outside to keep the moisture out and so forth. You don't need, in this small application, you're not going to get lugs with resin inside that's going to keep the moisture out in your car. You've got different connectors, automotive connectors. You've got connectors for the automotive industry that seal to some extent. I mean, I work in harsh environments too, and some of those waterproof sealers, just after a while they break down. It's just rubber, silicone, whatever it is, they break down and they allow water in to come through after a while. They do make connectors that help to stop the water, ingress of water, moisture and water. And if you're looking at doing that, you're better off using one of those connectors rather than trying to solder. I wouldn't solder because solder, if it breaks inside the insulation, you'll have a very hard time finding it. You'll have to measure the whole cable with a voltmeter, and then you'll be guessing where the break is. So if it breaks at the end with the lug is, at least it's broken off, and you can see it. It makes it a little bit easier to find when you're fault finding. Just said that's going to conclude my my wiring issues I have with the fuses. The wiring isn't an issue. I think the spec they use is too high for the wire that they used. 40 amps, guys. 40 amps will be a bit safer. It'll trip before that starts to catch on fire. A lot quicker than 80 amp fuse will. I don't think a 40 amp fuse is going to blow with charging the battery. I'm hoping it won't. I've never seen a battery go so high. Back in the day, 30 years ago, 20, 30 years ago, when I used to charge batteries were charging at, I don't know, 4-6 amps, thereabouts. I think battery technology has moved a bit since then, and whether it be the lead that they use or whatever they use or how they manufacture it now, I've seen it on the internet in a few videos and so forth. Batteries drawing 17, 18 amps, 20 amps, so maybe battery technology has moved quite a bit in that time. But certainly if you're looking to use this for lithium, I think lithium can charge quite quickly. It'll be interesting in the years to come how these things are going to pan out, because if you overstress the insulation with too much current, because that's going to heat up a lot at 70 amps. If I have to draw there 70 amps continuously, which I should be able to, that's going to put a lot of heat, a lot of stress on that insulation. Doesn't matter how good the insulation is, it's quite good, it's 105 degrees rated at, but that's going to it's going to derate, it's going to damage that very, very quickly, a lot quicker than you want it to. The life expectancy of that cable will be reduced immensely at 70 amps. So if you want 70 amps, run two lines, guys. That's all I've got to say. That's going to be a wrap up on the cable issue that I have. We're going to wrap that up with that, and I don't know, what are your thoughts? I mean, I'm interested in what Sparkies have got to say. Water electricians as well, electricians, electrical mechanics, fitters, whatever you are. I know there's some aviation engineers out there, electrical engineers. Prove me wrong. I don't think I am. I don't think that an 8 gauge cable of this calibre, is going to hold a continuous 80 amps. Prove me wrong. Yeah, that's all I've got to say. What are your thoughts on the issue, on the cable? Can they handle that continuously for an extended period of time? I know there's a duty cycle, but that's not the point. We're not talking about duty cycles here. There's no rating on the duty cycle on this cable from what I can see, or anything mentioned about duty cycles on this cable. I just don't see it holding up to 70 amps in the environment it's intended to be used in, even less. What are your thoughts, guys? See you next time.